For the first part of this question, we shall show that for t in 0 up to t minus 1, the expectation under Q of C, I shall write C for CE, just because in this case it's going to save heavily on some notation. That the expectation of Ct plus 1 over Bt plus 1 is greater or equal to the expectation under Q of the discounted C, so that's Ct over Bt. So, starting with the left-hand side, first by definition of C, this is equal to the expectation of the discounted asset price, S tilde t plus 1, that's S divided by B, minus this constant K over B t plus 1, which we shall write, for the moment I shall keep it as Bt plus 1, actually, plus just the positive part. Using the Tower property, or the Tower law, this is equal to this nested expectation, nothing changing here at all. This is the absolute magic of the Tower law. Since taking the positive part of a real valued random variable is, or of just a real valued number, is a convex function, we can use Jensen's inequality for conditional expectation to see that this is greater or equal the expectation of now everything inside the expectation and then taking the positive part. Then we can use the fact that Q is an equivalent martingale measure, so S tilde is a martingale under Q. See that this is equal expectation Q S tilde t minus k, so that should be made clear that that's a t plus 1 over b t plus 1. That's, b is just it's not random, right? I mean, it's just the fixed value of 1 plus little r to the power of what t plus 1. In fact, I should write it as that, which means we can take it out of the expectation, the conditional expectation, without problems. All plus the positive part. This now is greater or equal the same, but with 1 plus r to the power of t instead of t plus 1, because when we reduce the power there, that thing on the right hand side is getting larger, and so minus taking the negative of it is getting smaller. So we've got greater or equal this, which by definition is the expectation of Ct over Bt. Thus we have the inequality that we needed. Now for part B, again we want to use the fact that the function from x to x plus is convex. Since this is true, we have that CTA, so I'm going to move back now. I used just the notation C above, but that was always CTE. and now we want to keep them separate. CTA, which is the sum from 1 to t, 1 over t, is j minus k, plus is less than or equal the sum, j equals 1 to t, of the same but with the convex function now inside. You could use Jensen for that, but Jensen is even stronger than is necessary, which is equal to just the sum over now CJE. Thus, by linearity and monotonicity of expectation, the expected value under Q of CTA discounted less than or equal, this is just linearity, that should be J, we're summing over those, and B is still T. But that BT is, we can substitute now that instead to take a J, so J is smaller than T, and since R is greater than or equal 0, that means that B is going to be greater or equal 1. So taking a smaller value on the bottom increases the whole thing, and that's linearity of expectation. And finally, no, that's all we need to show. There is no finally. Now the last part follows directly by combining the results of part A and part B.